So the topic I'm going to discuss with you today is, well, a new concept that we are proposing, that we are trying to develop, in a way more conceptually than empirically, although I will show you several examples. It's a work that I'm doing in collaboration with Sarah de Rijcke and Noortje. And well, if I would start with something, I would say, I mean, the theme of this conference is essentially bridging worlds. And if I would say how do I envision this bridging worlds when we work with Altmetrics, with social media metrics, I would say, I mean, we propose this graph, and on the x-axis we have what we would call scholarly focus, and essentially we have one world on that extreme of that perspective, that is, let's say, the scientific world, where we have bibliographic databases, scientists, science, scientific papers, etc. Depending on many factors and many things that we could discuss, we could also say that we have another world that is what we would say the social media world, okay, or let's say the non-scholarly world that somehow is interacting with the scientific world. And I mean, in the past few years, we have been also, let's say, discussing how the scientific world is interacting with this, let's say, online or non-scholarly, not necessarily scholarly world. In a way, what we try to do, what I believe we are doing in basically what we do here, is try to somehow disentangle this science, society, science, social media, science, non-science interactions. In a way, I think we are doing a lot of work in this direction, but perhaps something that was missing in our development is, well, how can we frame what could be the framework we can use in order to study, to discuss these interactions? And this is going to be the main topic of my presentation. So, a way to study this type of interactions. In order to do so, I will use a classical model. So that basically is the framework we use in scientometrics, is the framework we use for analyzing citations. So on the one hand, we have what is called bibliographic coupling. That essentially is how publications are connected because they are citing the same publications, the same stuff. On the other hand, we have what is called co-citation analysis. That essentially is how publications, how papers are connected because they are being cited by the same set of papers. In a way, starting from here, we say, well, how can we apply these models or adapt these models to the analysis of social media events or Altmetric events? And let's start with a very basic type of act, let's say tweets. And we can easily say, well, okay, we can have two tweets that basically are linking to the same publications. This, we could say, is something like a tweet coupling. How tweets get connected because they are related to the same scientific publications. On the other hand, we could also look at how publications get connected through the tweeting activity. So, for example, papers that would be clustered in the same group, would be classified in the same group because they are tweeted in the same tweets. Of course, now someone would tell me, okay, but tweets are small or short, so then you don't have that many papers that are mentioned at the same time in the same tweet or in the same set of tweets. But I would say this model or idea of this type of models is that we can apply to multiple social media platforms, social media sources. So easily we could apply it to blogs. Okay, to blogs citing the same publications, we could argue that they are conceptually connected. Same thing for those publications that would say get connected because they are cited in the same blogs. So essentially, we are saying that we can apply some of the principles that we were using for citations also to some social media events. But we can go a step further, and we can also see how the actors, the agents, are also being connected, and publications or scientific objects get connected because of their interactions with these agents. So a simple example would be how tweeters are linked because they are tweeting the same publications. Or the other way around, how publications are connected because they are tweeted by the same users in Twitter. Just a very quick example. So these are publications from Nature and Science, and we look at how the tweeters tweeting those publications somehow get connected in this Twitter coupling idea. So essentially, every node here is a Twitter account, and they are closing the map when they are tweeting the same publications. I mean, this map is just for illustrative reasons. I mean, what most we can say is that we find some community of Twitter surround the science publications and some others surround the nature publications. But to me, it's more thinking, okay, what can we learn? How can we apply this type of analysis for other purposes? A type of analysis that we could develop, for example, is what we call communities of attention, essentially studying who are the users, who are the social media users around a set of publications, the publications of a university, the publications of a journal, a publisher. How diverse are those audiences? So we could dig into these maps and say, okay, how different are they? Are all, let's say, publishers, or in this case, Twitter accounts related to the journals, or they are more diverse? Are there scientists, are there citizens, are there NGOs, social users, etc.? Identification of stakeholders, or also identifying cognitive breaches. So if we find communities that are very polarized, can we identify users that are somehow breaching those communities? And now we can flip the metrics that we have, and then look at how publications get clustered because they are being tweeted by the same tweeters. So again, I don't want to enter too much into detail. This is the same set of publications that was used in the previous map. We can identify that some publications with some similarity, like the proteomic papers on the top, are being connected by the Twitter users, which somehow also supports that, okay, what happens on Twitter, it's not totally random. There seems to be some connection, some relationship. But again, the main idea is, okay, what can we do with this type of analysis? And a very simple application would be creating new maps of science. So in Altmetrics, we create maps of science based on citation relations. Why not creating also maps of science based on social media activity? In a way, it could give us something about, possibility of identifying something like societal clusters, so publications that are put together because some groups of social media users or online users are interacting with those publications. One could wonder, okay, why is that? Why those publications are being put together? That would also open the possibility of studying, let's say, other more problematic things like misinformation. When people are using, or users in social media are using or interacting with publications, they seem to be not properly connected. So we could dig into this type of analytics. Well, and we could go further. So apart from the events, apart from the agents, we also have what the reference formats, the affordances, that the different social media platforms allow. In the case of Twitter, we have hashtags. So we can see how, for example, how hashtags can get connected because they are attached to the same set of publications. Or again, how publications could be clustered together because they have been tweeted together with the same hashtags. So this is another illustrative example. So these are the top hashtags from the altmetric.com. And then we can see how we can identify clusters of hashtags that are related because they have been linked to the same set of publications. It's, again, the same concept as before. And so possibilities, applications of this type of analytics. Well, something like about the social tagging of science. So how social media users are referring, are linking, let's say conceptually from a tagging point of view, to scientific outputs. It could also be used to improve dissemination strategies. So, okay, I am publishing in, let's say, cancer, but there is also oncology. Maybe I could use these two tweets or use them at the different moments and try to, let's say, improve, make more optimum my dissemination strategy. Recommendation systems. So, okay, I'm following the hashtag about cancer, but then I may also get the oncology hashtag recommending me this paper may also be relevant to you. Well, and let's say topic modeling, other possibilities. So let me then try to simplify all this. Okay, that's also the main idea, to try to get a model that we can use for multiple purposes. So trying to simplify, I would say that basically what we have are acts. So this is also something that I did with Stephanie Houston and Tim Baumann. So we have acts that happen, say, in online platforms, social media platforms. So actually an act is a tweet, a retweet, a blog, a podcast, a Facebook mention, a Mendeley saving of a publication. So these are acts that happen on social media. Then we have agents. So you have someone, something that is performing that act. So that can be a tweeter, a blogger, a Mendeley user, any kind of let's say individual or group of individuals. And then we have forms of interaction, forms of engagement. So then is the tweet itself, so the tweeting activity, the retweeting, the liking, the sharing, the posting. So these are all different types of interactions. And actually they capture probably different types of engagement, of relationship with the science objects.
2 minutes.
And in 3 minutes?
2 minutes.
2 minutes?
2 minutes.
Okay.
They're hungry.
Well, okay. And then we have the science objects. So science objects can be basically anything. I mean, typically it's papers, could be data sets, could be software, but could also be universities, could be researchers, could be even research topics. And when this happens in multiple times, in multiple acts, we can create all the linkages between these different elements. So in a way, this would be the simplification, the generalization of the model. So on the one hand, we would have any kind of social media elements or acts, agents, technical features that are connected because they have interactions with scientific objects. And on the other side, we have what we would say scientific objects that are connected through social media events, okay? So events that put them together. I would stop here and then make David happy, but when I look at this, I also say, yeah, I have the impression that life can be more complicated. So I suppose that I would switch some of these boxes and make this. I say, well, this is theoretically possible. So we could get combined linkages of social media events and science objects also being connected by science objects and social media events. And I mean, a very simple example would be, okay, suppose a blog and a paper, I can tell you they are not connected directly, but both cite the same paper. And to make it even more complicated, both cite another blog. So then this now makes the distinction of the social media world and the scholarly world a little bit more complicated. So I would say it is indeed a very heterogeneous world we are dealing with. Just to show you a very simple, of this more, we'll say, heterogeneous perspective, a very simple application is studying what we call the semantic spreading of scientific topics. So these are the top author keywords related with big data, publications related to big data. So green nodes are author keywords, and red nodes are the hashtags that have been linked to those publications via tweets. So essentially, we have a combination of publication tweets. So what is interesting to see here is, for example, how sometimes those author keywords and hashtags align, so they are the same. Sometimes there is a narrowing down through the social media, so authors say social media, but tweeters say Twitter or Facebook. And sometimes we find something like a broadening up. So researchers are saying my paper is about machine learning, but are the Twitter users who say this is artificial intelligence. So, okay, so there are also plenty of applications of this type of analysis. I will just like to jump to the future. Basically what we need to do is to dig into this diversity of acts, agents, interactions, and probably it's in the modeling of these different elements where we are going to find the possibility of developing analytics indicators that will tell us a lot about this interaction of different communities, scientific and non-scientific. And I will stop here.
Great, thank you very much, Rodrigo.
Good morning, everyone. It's my honor to be here to present my work, Hunting Technological Treasure of Science, a Novel Indicator. This is a work in progress, so I appreciate very much your constructive comments in the end. This is a snapshot of my presentation, which consists of 6 main sections: introduction, research question, methods and data analysis, and findings and some discussion. For introduction, I would like to start with some debates in innovation and altmetric literatures. In innovation, the debate has been going on about the role of science linkage in generating impactful innovation, and also about whether high-impact science leads to high-impact technology or not. And in Altmetrics, the discussion is about whether high-impact science also gets high attention in the online media. And we can come up with a question, what type of research should we fund? Should we fund basic research? Or should we fund market-oriented research? Or should we fund research with high technological value? And currently, from a more practical perspective, we have supporting programs for science-based emerging technologies with different dimensions, different measures of performance. However, all the metrics that currently applied are conducted separately. For example, the scientific excellence based on citation impact, technological implementation, or societal effects. So all the metrics are separate metrics. So in my research, I would like to ask the question, can we capture the extra value of science apart from the traditional citation impact? And in the end, I would like to find a new performance indicator for the technological value of science. Here are my two research questions. The first, to what extent does scientific impact and science popularity influence technological impact? Why I say science popularity here? Because I think that I learned from Altmetrics literature. I would say that the more popular the scientific papers are, the more value they can bring to the society, especially when they are reached to the community of inventors and innovators. And the second question, what captures the additional value from science that influence technological impact? To answer those research questions, I trace the linkage between science and technology via scientific non-patent reference, which are the scientific publications being referred in patents. And to answer the first research question, I used two models. The first one estimates the impact of science, the influence of science impact on technological impact. And the second model is the impact of the influence of science popularity on technological impact. So these are two separate different models. And then I compare, in the end, I compare the impact of each IV1 and IV2 on the DV. And to answer the research question 2, I run a model 3, which I estimated the effect of science impact and science popularity on the technology impact. And I also, in the end, I also checked the interaction effect between IV1 and IV2. And you can see some proxies for the dependent and independent variables. So the unit of analysis here is the patent application. So, and I also introduced some control variable, and science popularity here is proceed by the adjusted Altmetrics attention score that Altmetrics provided me, but I excluded the mentions of the papers in patents. My data come from 240 patent applications, US patent applications with the scientific reference dated between 2011 and 2015. And this is, I take the case of DNA nanotechnology as an example of science-based emerging technology where I can observe the linkage between patents and publications. And I get the data from past start, the patent data from past start, and the bibliometric data from Web of Science, and Altmetric data, as you can see, I get from Altmetric. But we have some challenge. The biggest challenge was the high correlation between science impact and science popularity. And the Altmetric data we cannot retrieve by window. And so I also came up with some solution. So I regressed science popularity on science impact, and I take the residual in the, I'm talking about model 3. So then I replace the residual, I replace the residual of IV2 into the model 3. And I use a principal component analysis for 12 subvariables. These variables are the mentions of the papers in 12 different sources provided by Altmetric. But in the end, I only took the two main components which accounted for 74% of variation of all variables. And so this is a modified model for model 3. And this is the detail of my principal component analysis. So these two components are supposed to be my new indicators which capture different aspects of the online media attention. Or in my research, I would say like science popularity. And this is a correlation matrix of all variables in which the yellow variables are removed because of high correlation. And this is the result of my first two models which estimated the impact of science impact and science popularity on the technology impact. And the model is shows significant, and as you can see, the model with adjusted Altmetric attention score is slightly better than the model with the science quality only. But please be noticed that this variable is not based on any window, but just up to date. And this is the results of my third model, and with some improvement steps for to treat the multicollinearity in model 3. And the results were significant. And this is whenever it has, whenever there is Altmetric attention score, there is no window attached to it. And here are some findings. I would say science impact and science popularity both have influence on technology impact. Science popularity can generate the additional value for science beside citation impact, and which could be used for upcoming performance assessment for science-based projects, science-based technology projects. And our new indicators capture different aspects of science popularity, and we found no significant interaction effect between science impact and science popularity. And here are some discussion. So I would elaborate more on the theory of science popularity, which has not been discussed in the literature. And science popularity provides some signals for technology developments that if we can measure it, we can maybe forecast a new upcoming technological developments. And even if good or bad science when it's discussed in the online media, and it is really helpful for the practitioners, inventors, and examiners. And the third discussion or suggestion for Altmetric, would it be better if they could provide provide data based on Windows? And the last one, I think that it's not very clear for me why, because nowadays the online forms of science communication, like reading abstracts, I see that it can absolutely replace reading a full paper. Especially when I look at the patent data, they refer more about abstracts more than the full paper.
1 minute.
Yeah, and that's all. Thank you very much for your attention.
Good afternoon, my name is Mike Taylor. I work at Digital Science on Altmetric and Dimensions. I'm going to start with a slight sidebar. Yesterday there was some discussion about the performance of journals in terms of where attention is derived from different kinds of journals. This is a slide that I just happen to have in my laptop. It's one that I generated earlier this year using Vosphere and Altmetric data. So what I did here is to do a search for gene therapy in Dimensions and exported the data into Altmetric and did a little bit of an analysis on it by attention source. And what's quite interesting is that even in this relatively small field of about 10,000 research articles, you get a very distinct pattern of attention sources. So we've got a big cluster of journals that get quite a lot of news attention. And we have a large cluster of journals that get a large number of patent citations. And this is quite interesting for me because when you look at different forms or different areas, you get very different characteristics to these networks. This happens to be quite a mature field where there's quite a lot of intellectual property being created by articles that are in these journals here. If you have a chance to look at the high-res version of this, you'd notice that a lot of these journals have got therapy in the title, so gene therapy, current gene therapy, clinical, they're very translational, they're very focused on delivering product, whereas the journals that get a lot of news and blog attention are clinical, they're New England Journal of Medicine, they're very broad-based. And this is quite an interesting phenomenon. What I'm not suggesting is that the same article would get different kinds of attention in different journals, rather than that even within this relatively small topic, there are different hotspots of attention, different stages of delivery of the research. And like I said, this is within quite a tightly defined field of research. So I wanted to talk about models of the research and when it is more appropriate to be thinking about research as an industrial scale of activity. I expect that most of you are very familiar with the typical models that are presented that show the research life cycle. So you usually have a linear model, and on the left-hand side you have a cluster of squares that have got dollars in them, and they say, money being made available, people applying for grants being awarded. Then in the next stage you've got data being created in the laboratory. Then you've got journals, publications. Maybe you've got citations as the fourth blob in this linear research model. And when people are really daring, they turn the whole thing into a circle, and there's this suggestion that we have this perpetual cycle of money going in and people acting on the money. And it's a very industrial level, but it's a very simple model. It's a very deceptively simple model. This gentleman is not, as far as I'm aware, a relative of mine. His name is Taylor. He was one of the people who came up with the idea of scientific management. And when you look at it, it is very focused on measurement, it's very focused on productivity, it's very much focused on delivering quality at a known rate and at a known level of quality. And if we were, for example, to say that the key measurable of the research lifecycle was the number of publications per year, then we end up in a situation where we optimize our performance to delivering according to that particular metric. Simple models produce simple answers, and sometimes those are deceptive. Because one of the questions for me that is quite interesting is whether research is an industrial scale activity or whether it is an artisanal activity. We can certainly see characteristics of both of these things in the research lifecycle. If, for example, we take the Diamond Light facility at Harwell in Oxfordshire, this is a massive industrial scale piece of investment. You can certainly use industrial type models to understand the investment and the performance and the output of an institute such as that. But it's a very human level. As the gentleman who works at Diamond Light, it can work on a very detailed, focused level. These are two of the Dead Sea Scrolls which are currently being read using technology at the Diamond Light facility. So we have numerous different levels happening at the same time. We have both industrial processes and industrial scale, but we also have artisanal process. And this is because research is a human artifact. It's evolved over time. It's not something that has been created to a fixed idea of how we create things. We're not, as people who work in academia or work alongside academics, trying to create the same kinds of meals or cars over to a known level of quality time by time after time. Rather, we are individual people working, contributing to individual fields. And when we look at those fields, we see that there's a great deal of nuance going on there. If we take a field such as autonomous vehicles, for example. 5-10 years ago, this was largely focused on AI. It was all about the software. Then a little bit after the software peak, about 8 years ago, you start seeing people looking at the hardware. They're looking at sensors. Now, when you do an analysis of where the topic of autonomous engineering is, you start seeing ethics, you start seeing philosophy, we start seeing legal scholars writing about the implications. So even within a very small field, really tightly defined, we see these different shades of light and dark appearing within a topic as it develops over time. It's not a linear process, it looks more like an artisanal process. Different people making different contributions according to their skills to shape the development of human knowledge. So I wanted to talk about a particular area of research. So it's an academic research, and if you go to a tool like Scopus or Dimensions, do a search for sexual harassment and Me Too, you'll see that there's a level of academics who are creating outputs in this field. It's a relatively small field. But what I wanted to show you is how this has changed as a consequence of the Me Too phenomenon, how that has, the social conversations has changed the nature of academia in this field. This is not by any means a one-off. Almost all topics show different levels of responsiveness and reactiveness to social need. So the red line here for Google searches is for Me Too searches. So up until October 2017, nobody has ever gone to Google, as far as we can tell, and searched for Me Too, hashtag Me Too. And then Harvey Weinstein happens, and then we get this little peak of activity, and we still have a level of activity, still have people going onto Google and looking for Me Too. In contrast, the blue line shows a very steady state of interest in sexual harassment until Me Too happens. And the interesting thing for me here is that the peak of people who are searching for sexual harassment is very much bigger than Me Too. It persists over a longer time. It has been sustained as a consequence of the Me Too phenomena. So it is not quite double. It's gone up by about 50-60% over time here. So what you get the sense here is that a viral phenomenon of the Me Too phenomena, the hashtag Me Too phenomena, has kickstarted a conversation about sexual harassment, which has persisted 2 years late. This is about 18 months after the phenomenon. So my question here, my research question from this topic really is to see whether the Me Too phenomena has affected the role of scholarship in this area. So 2 or 3 years ago, if we had had a workshop of people who were working in the field of sexual harassment, we could have fitted them into this room, right? And we're talking about a really small number of academics who are doing scholarly work in this field. And if we have a look at the number of outputs that we see, so this is data that's come out of Dimensions, and it's looking at different kinds of outputs. So the axis on the right-hand side is for articles, and the axis on the left is for reviews and chapters and so on. And there's a couple of phenomena there that I want to point out. So 2017 is the year of Harvey Weinstein. 2018, we see a doubling in terms of the scholarship in this field. We've gone from about 250 research articles, about 32 chapters being published in 2017, and that's doubled. We've got over 60 chapters being published in 2018. We've got over 500 research articles being published. Likewise, we see a tripling in the number of review articles. We see a large increase in the number of proceedings being published. We don't yet see a rise in the number of monographs being published. So this is what happens as a consequence of that Me Too phenomena. It's doubled the size of this field. And if 2019 looks small, that's because I pulled this data out in the summer. It's about halfway through. I confidently predict that these bar charts are going to be well up there by the end of the year. I look forward to rerunning this article. But the other phenomena that's going on here happens actually a little bit earlier, because in 2015 we start seeing a large growth. And in fact, that line there, the growth of research output, is larger than you'd expect in any baseline. And that's quite an interesting phenomenon, because it suggests that even before the Me Too phenomena, we had a growth in the number of academics who are working in the field of sexual harassment. And this can be seen even more abruptly in altmetric data. So this is this is altmetric activity per year, so not by publication, but by per year, for articles that either mention Me Too, hashtag Me Too, sexual harassment. And there's a couple of really interesting phenomena here. So again, this is the year of Harvey Weinstein, 2017, 2018, really very high volumes of news articles being published here, bearing in mind that we've also got this massive jump in the number of research outputs going on at the same time. So there's a very big, there are lots of conversations, almost 1,000 mentions of scholarly research in the mass media, like about 180 blog posts. But we want to go back and look at what was going on in earlier years, because actually the uptick in the number of people blogging about being engaged by research in sexual harassment can be dated back to 2016 in the case of mass media and 2014 in the case of blogs. So what we have a sense here is that there is a community of people who are engaging with research in this space before the Me Too phenomena happens. And I have a hypothesis about what's going on there. In terms of Twitter activity, blue line here, average number of tweets per active article. So very high numbers indeed. You know, we've got an enormous number of people here who are sharing the results of the outputs in this field. Mendeley is quite a typical curve for a very long active attention source such as Mendeley. But these numbers for a humanities field are very high indeed. There is a large number of people, typically postdocs, PhDs and postdocs, who are sharing, curating articles about sexual harassment and Me Too on Mendeley. However, if we were just looking at citations, we would see none of this. As far as the citations line is concerned, the green line here, there's almost no activity. You don't see anything there at all. And this is one of the things that I want to push out there, because what we see when we look at topics at this level, we see phenomena happening at different times, different stages. We see how the loci of attention changes as a topic develops. So, you know, back at the beginning of my presentation, I criticized the simple model that shows funding as the beginning of the research life cycle, the way that it's usually presented at conferences. And this for me is a really interesting thing. So going back to the publication output and altmetric, that beginning of the growth of people interested working in the area of sexual harassment takes place at a time when this is a very underfunded and very still flat level of investment in this field. What happens in 2017 is we start seeing an increase in the amount of funding. Now, we mustn't forget that some of this is retrospective. So people publish their funding data in the years subsequent to when the funding was made. So it's always slightly looking back, but it's looking back to the beginning of a process. So normally what we see is a downward line at the end for the current year, because we haven't got the data yet. When we look at this data, and bearing in mind 2019 was only halfway through when I created this line, we have seen that the amount of money being invested in the field of sexual harassment and Me Too has jumped from about 2.5 million to almost 5 million. By the time I redo this graph at the end of the year, it will be somewhere in the region of 6.5, 7 million. The Harvey Weinstein effect has almost tripled the amount of investment going in there. This is not a field that is being led by funders. This is a field that is being led by social interest and by social need. And we can see the appetite for research in this field as well. If we look at the number of policy mentions, the number of policy citations, so up until down here, we have a very low level of policy citations going up till about 2016. It's not until we get to 2017 and 2018 when we start seeing these very large peaks in people citing the research in sexual harassment and Me Too in grey literature documents. So again, it tells us a little bit more about the complexities of how topics fit together and how they develop. When I do these qualitative level studies, they tend to be different for all different fields. Even where you think you're going to find two that are the same, you tend to find different phenomena going on there. I find it a very interesting and a very rewarding way of looking at data. Because, you know, for the last 10 years of my career, I've been doing industrial scale analyses. For the last year and a half, I've been doing these sort of more micro-level scales. They're equally rewarding. They work at different levels. The question really is to know when is the appropriate time to be using a small, detailed level of focus versus a heavy level of focus. Not to run away with the data, not to get enthused by the scale of data, but also to use small-scale data as being cues to investigate the underlying phenomena, not just hand over a spreadsheet and think your job is done. Not generalizing. This is a picture of my cat making a huge generalization. I'm opening up a can of food. It hopes it's Whiskers. It's grapefruit. Thank you.
Thank you very much, Mike. Okay, and our final speaker is Nadiia Zubchenko from the National University of Ukraine. So, Nadiia.
Okay. Okay. I want to start from the question, what is the article worth? On the one hand, it has a scientific value, and from the other hand, there is a price that author pays for publication, and it's not every material price. Very often it is a price of reputation of the author, of the scientist and scholar. I should tell you a short prehistory of this study. In 2015, the Ministry of Education and Science of Ukraine prescribed all the scholars who want to obtain scientific degrees of Associate Professor of Doctor in Science to have obligatory publications in Scopus and Web of Science index journals. Only this, and only starts from 2 articles. And it was rather controversial, but it exists, and let it be. And then in late 2017, we faced with the fraudulent practices, of which led to 3 images of scholars, not from our university, but from other universities in Ukraine and Europe. These were predatory publishers of new generation, not predatory publishing in that means that we all knew about that. And all our scholars rushed to prepare manuscripts for journals, and it should be mentioned that the principles of academic integrity were breached. So there was, because of the lack of information about the publication process, about journal policies, and about open access, and most of Ukrainian scientists, especially in social sciences, think that any publication in impactful journal costs a lot, and it is hard to do. And also most of the social scientists know about a little about predatory publishers, and this you can see on the diagram that most of Ukrainian scientists know about the academic integrity of publishers' integrity, but a part of them doesn't know. Choosing a journal, we are guided by various factors. Someone is looking for well-known journals, someone tries to publish in a journal that he knows for years, someone just starts his scientific path and almost doesn't focus on the academic publishing. So a scholar is faced with a dilemma, what to choose, honest publisher and make his research famous, or to become a victim of predatory publisher and curse his choice. Who are predatory publishers? Someone considered that predatory publisher is just website that's posing him as a scientific journal. So no one immune from fraud that can get very strange images, such as predatory publishers or fake journals or someone else. It is widely recognized that these publishers which do not adhere to generally accepted norm, and I started legal analysis of the activity of this publisher because I have a PhD degree in law, and also I'm on the junction of law and library science because I'm a librarian. And I developed a method that can help to analyze the activity of predatory publishers. And this method is multidimensional and includes both legal means and tools of scientific communications. So, we have a fake journal, and on this example we can start to use our method. So, the method includes legal means and tools on scientific communication, and the scientific communication is the main path of this analysis, and is conducting such an analysis in most important factor. And because the evaluation of publications and publishers is significant, and this is the main, I think, factor that influences to the choosing of the journal. As for the predatory publishing, not to be ungrounded, here is this bright example of the that I met in internet, that our publishers and our scientists met. This is the famous Law and History Review of Cambridge University Press, and that one is a fake journal which use editorial data of ICCN and other data of real journal. So the front matter is identical. Then the second, we can see that number of issue and volume and other editorials are different. Then different of ICCN, because this ICCN is not existing, which in fake, and in original journal there is no any information about ICCN, but on the website we can find it. Then in real journal we have only one page with the editorial board, and this editorial board changing every volume that I know. And in fake journal there is a editorial board with fake scholars who doesn't exist. Then real content page is near 10 articles, and in the fake journal there was about 80. Yeah. Then in the text we can see the difference. After this, we decided to make our efforts to combat this publisher. And firstly, we claim to search giants like Google to block the website of in the search result. And we make a claim to original publisher, to Cambridge University Press, to provide them with information of the violation. And we received a lot of letters all around the world, and we received claim in Lumen database, which described the copyright infringement and the resolution to block this publisher in search results. And then we started our communications with other law schools, especially the University of Adelaide posts a big, I think, information about scam warning, about predatory publisher, and so on. And many leading universities and law schools started to warn their scholars about such publishers. And we also started to write some articles in leading journals of informatics or bibliometrics. And we started to make initiative, to do initiative in Ukraine, like cables list or bills list. And we started a project Open Science in Ukraine, which can give an information about publishers, about journals. And after this, we found that there is a legal practice on fraudulent practices of academic publishing, such as Federal Trade Commission of the United States versus a mixed group. And this case led us that it can be different qualifications of the activity of predatory publishing from the legal point of view. We started to search some information about activity of predatory publishers in the legal field, but there is no information, there is no any information about that. And considering the practices of verifying data of journals, it is possible to distinguish two types of predatory publishers' activity. These are copyright infringement. This includes publications in non-impactful or unofficial journals, including scholars in editorial boards without their permission, then reprints of publications without permission of authors or publishers, etc. And the second one is fraudulent practices. These are the reprint without permission massively, then use of titles, ICCNs, editorial boards of leading journals, then substitution of impact factor, publication data, and manipulation with personal data. And I should ask you about what I think about publishers' reputation. Does it matter? Okay. Who guess? Yeah? Okay, I also think that it does matter because this is the main factor of academic integrity. And we should all make our efforts to make academic publishing more honest. And then another question, is it lawful to use the source data, like ICCN editorial boards of one journal to publish another journal? This is a small part of my research, so I ask you these questions. Yeah? Do you agree? No?
2 minutes to go.
No. Yeah. And this question, are you agree with it? Yeah? Okay. And from the legal point of view, what's this? A lot of information, a lot of research led that it is a fraudulent practice, but in some cases it can be a criminal offense, but in some cases it can be violation of consumer rights, and there is no one qualification of this activity of predatory publishers, and taking into account some of the cases and extent of fraudulent practices, it is worthwhile to deduce a term publisher's integrity into agenda, because it can be checked with the simple tools, and all metrics, alternative metrics and scientific metrics are measures that can become a real means of preventing fraudulent practices in academic publishing. And that's all. I think you have many questions for it, but this is the research in progress. So thank you very much for your attention.
Thank you, Nadiia. Okay, thank you very much to all four of our speakers. We have overrun slightly, so I suggest if we have questions for them, we maybe pick that up over lunch. Lunch is in the Abbey Craig dining room, which is where you probably had breakfast this morning, and we start again at 1:30. So see you back here at 1:30. Thank you very much.